Okay, picture this. You're lying in bed, just staring up at the ceiling. The fan is spinning, it's cooling the room down, but, well, there's a problem. It's shaking. It's rattling. Honestly, it looks like at any given moment, the whole entire unit might just detach from the ceiling and launch itself across the room. We've all been there, right? You watch that daily wobble and this creeping, mild panic sets in. You find yourself wondering, is this thing actually dangerous? Was it installed horribly wrong? Or is there something else going on up there?
Welcome to today's Explainer. Today we're going to completely demystify that common household terror. We're going to figure out exactly why ceiling fans wobble daily in living rooms and bedrooms all over the world. Our goal here is to swap out that mild panic for a really deep appreciation of the beautiful invisible laws of physics that govern our world. Because as we break down exactly what is happening above our heads, we'll see that a wobbling fan isn't usually some disaster waiting to happen. It's actually a fascinating, real-time physics demonstration happening right in your own home.
Section 1. The Wobbling Fan Mystery. We're uncovering the invisible forces right above our heads.
So, before we can really talk about the why, we kind of have to define the what. When we talk about a wobble mechanically, what we're actually describing is an unstable motion. In a perfect world, a ceiling fan should rotate in this perfectly smooth, continuous circle right around its central point. But a wobble happens when an object moves side to side instead of rotating smoothly. It's a disruption. And the crazy thing is, even the absolute tiniest imbalance in the physical structure of the fan can instantly ruin that perfect circular rotation and turn that smooth motion into the shaking we see every single day.
Section 2. The Center of Mass, or the Search for Perfect Balance. You see, every single object in the universe has a center of mass. It's that exact, precise point where its weight is perfectly balanced. Think about a theoretical perfect fan. All the blades are completely identical, the weight is evenly distributed across every single inch, and the center of mass is sitting exactly dead center. But then, you have your messy, real-world fan. One blade might actually be microscopically heavier straight from the factory. One might be slightly bent because, someone bumped it. Or, and this is super common, dust collects unevenly on top of the blades over time. Suddenly, that center of mass, it shifts away from the metal.
Section 3. Unbalanced forces and torque. How we go from tiny dust to massive shaking.
When that off-center, unbalanced fan starts spinning, it wakes up a totally crucial physical force, centrifugal force. You've definitely experienced this if you've ever been on a spinning merry-go-round at a playground and felt yourself being physically pulled toward the edge. That's centrifugal force. It's that outward pull experienced by any object when it rotates. Now, when all blades on a fan are perfectly equal, all those outward forces just cancel each other out, giving you a totally smooth rotation. But an unbalanced fan? Yeah, that's a whole different story.
Now, please don't let the math intimidate you here. It's actually really beautiful in how simple it is. The formula for centrifugal force is F equals m times omega squared times r. Let's just look at the variables. M is the mass of the blade, the Greek letter omega represents the speed of rotation, and r is the distance from the center. I want you to focus just on that m, the mass. If one single blade has more mass, maybe just because of a thick clump of dust, it fundamentally changes the equation for that one specific blade. That slightly heavier blade now experiences a mathematically stronger outward pull than all the other blades. It basically creates a wildly uneven force distribution.
And what's super interesting is how this plays out like a literal set of physical dominoes in real life. Step 1, the mass shifts off-center because of that dust or a heavy blade. Step 2, because of that extra mass, the outward centrifugal pull increases sharply on just that one side. Step 3 introduces torque, which is just the force that actually causes rotation. But instead of equal torque, that heavier blade produces more torque, actively pulling the fan off its axis. And finally, step 4. This uneven torque forces the fan to physically tilt slightly while it's spinning. That repeated tilting, that is exactly the side-to-side oscillation we call a wobble.
Section 4. Resonance and gyroscopic effects. Let's look at why speed changes the wobble.
Have you ever pulled the fan chain and noticed this completely bizarre timeline? So on low speed, the fan seems perfectly stable, all good. Then you pull the chain to medium speed and suddenly the wobble heavily increases, like the whole fixture is violently shaking. But then you bravely pull it one more time to high speed and wait, it somehow becomes completely stable again? No way, right? Well, this counterintuitive behavior happens because of something called resonance. Literally every single object has a natural vibration frequency. When your fan hits medium speed, it might perfectly match that natural frequency, which massively amplifies the vibrations to their peak. Speeding it up even further pushes it past that natural frequency, settling the whole thing back down. So here's the real kicker. A spinning ceiling fan actually behaves exactly like a gyroscope. Normally, gyroscopic motion is great, right? It helps keep things perfectly stable. But when you introduce that tiny imbalance we've been talking about, the fan can't just have a simple linear shake back and forth. Instead, it triggers something called gyroscopic precession. This is when the fan begins this complex circular wobbling dance, swinging all the way around its axis rather than just shaking. It looks absolutely terrifying, but it's really just the fan reacting precisely the way a gyroscope is supposed to react to unbalanced torque.
Section 5. Real-life wobble causes. Let's bring all this heavy physics back to your living room.
The things that actually trigger these massive laws of physics on a daily basis are surprisingly mundane. Like what throws off that perfect center of mass in your house? Well, sometimes it's literally just unequal blade weight straight from the factory. More often than not, it's just dust accumulation on the leading edge of one blade. It could be loose screws that are allowing a single blade to sag, which fundamentally changes its angle and torque. It might be bent blades from someone tossing a pillow across the room, or even just improper installation where the base isn't totally flush with the ceiling. Because of the physics of rotation, even a tiny difference in any of these areas creates a highly noticeable wobble, especially when you crank it up to high speeds.
If you want a perfectly grounded mental anchor to remember everything we've just talked about, honestly, just think of a bicycle wheel. It operates under the exact same rules. If the spokes are tuned and the weight is evenly distributed all the way around the tire, you get a perfectly smooth ride. But if you were to tape a heavy lead weight to just one side of the rim, what happens? As you pedal faster, the wheel starts shaking violently, transferring all those unbalanced forces right up into the handlebars. A ceiling fan works the exact same way. It wobbles because its mass is no longer evenly distributed, leading to unbalanced outward forces, uneven torque, and all those visible vibrations. So, the very next time you're lying in bed, staring up at that shaking ceiling fan, you'll know exactly what's going on up there. It is not a loose screw plotting your demise, it's centrifugal force, torque, and gyroscopic precession performing a daily dance right in your bedroom. Which honestly brings us to a final thought for this explainer. If something as incredibly simple as a ceiling fan is secretly ruled by such massive, invisible laws, ask yourself, what other hidden physical forces are spinning around you in your daily life just waiting to be understood?